Hello guys. So today we are here to solve this spiral matrix problem, and this problem is a very famous problem, and I'll show you how to solve this problem. So first of all, before going in to solve this problem, we need to understand what this problem is all about. So we are given an m cross n matrix. So this is not a square matrix, this is m cross n matrix. So m is the number of rows and n is the number of columns. So the number of rows need not be the number of equal to the number of columns. So m and n are different. They can be different, they can be same, it doesn't matter. So in the problem, it is said that m cross n. So it need not be same. It could be same, but it need not be same. Okay. Now with this, we go ahead, return all elements of the matrix in spiral order. So we have to go from 1 to 2 to 3 like this, in this way, spiral order. Okay. So if this is the matrix, then we have to go first, we have to go left. First, we have to go left, then we have to go down, then we have to go right. Okay, this is no, this is right, this is down, this is left, and this is up, and then we are going to coming back to uh, right. So initially we were right, then we are going down, then we are going left, then we are coming up, and then again we are going right. So right till the point we can go, because this point is already covered, so we cannot come to this 8. And there are some constraints. So I am telling about this constraint because I'm going to use one such constraints. And the constraint is that the matrix content of the matrix contains numbers between -100 to +100. So I'm going to use this fact. So if something which is beyond this range, -100 to 100, it means that that is not what originally the matrix used to contain. Okay. So with this fact, I'll try and I'll solve this problem. Okay. So now we have to return a list of integers. So it's better that we first declare that list. Okay. Okay. And then we'll be calling this spiral. Okay. Like this. And then we'll be passing this matrix. And then we'll be passing 0 because we want to start from that 0th row, 0th column, and then we'll be passing this string. Okay, right, because the first direction that we take is right. In this matrix also, the first direction that we take is right, from left to right. Here also from left to right, because the first row has to be covered first. So left to right, and then we'll be passing this result matrix. Okay, and at the end, after finishing all this, we'll be returning the result. That's it. Okay. Now we'll be taking this private void go spiral. Okay. And then we'll be passing this int array matrix, that int row, int column, string direction, and then list of integer result. Okay, like this. And so the first thing, since this is going to be a recursive call, so first thing we need to check, like, what is the boundary condition. So the boundary condition, like if row is less than 0 or row is greater than equal to matrix dot length, or call is less than 0, or call is greater than equal to matrix of row dot length, or matrix of row and call is equal to -101. So remember, we said that the initial constraint of the matrix is that the content of every cell of the matrix will be lying between -100 to +100. So we'll be populating this matrix with something which is beyond that range. So like something like 1 -101. So if any matrix cell contains -101, then it means that it has already been visited and we did not visit that cell again. So if we come across that cell having -101, then we are going to return immediately. So this is that we are taking care of this thing here. Now, so result we have passed, and that is one linked list, and that linked list is going to contain the uh, you know the list of elements. So matrix row column we can do, and then matrix of row call is equal to -101, like this. And then we'll be checking this direction dot equals. If the direction equals right, then what we're going to do, we are going to go, we'll be calling go spiral. Okay, go spiral of, so we'll be passing this matrix, and then row will be as it is and call +1. Okay, so we will have to put this check over here. Okay, so we have to put this check before doing this call +1. So what is the check that we need to do? That call +1 should be less than, less than equal to, less than matrix of that row dot length, like this. Okay, matrix of row dot length and matrix of row or call. We need to put this one more thing. Call +1 is not equal to 100 -101 -101. So in that case, we'll be giving this call to go a spiral. Okay, like this. So call +1 is less than matrix of row dot length. Okay, and is not equal to, like this. Else, so in the else part, we will go, we'll copy this row call, and now, okay, we have to pass the direction also. So we'll be passing right. Okay, and after, why we are taking else, like else is taking, like in case we come across the condition that call +1 becomes, it becomes, it goes beyond the matrix limits, matrix boundaries. So in that case, what we are going to do, we are going to give a call after traversing the whole right, row. In the same row, we will be going down. So I'll pass the direction as down. Okay, so down will be our one string. Okay, and then down will be doing like this, and then this, and this will also be a string. Okay, like this, and then else if, so we'll copy this, sum equals down, like this. Okay, in that case, what we will do, so we'll take this, so we'll modify this. Okay, and this we are going to modify this. So now we are going down. So if when we are going down, we are going down, this is the down traversal. So when we are going down, what do we need to do? we need to do row plus 1. So we'll write row plus 1. Row plus 1 will be matrix, it should be less than matrix dot length, and here it will be row plus 1. That condition will be row plus 1, and then call will be like this, and then in this call will be leaving this. Okay. Okay, so we'll be writing this as row plus 1, and then this will be this call. So if somebody looks at it, okay, and then it will be after we are done with this, we'll be doing call minus 1, and then this will be not right but will be reverse of left, and then again we are going to take copy of this, okay, and put this thing here, and in this case we'll copy this, put it here. Okay, this same call will be used in this case. So if we are using this same call, we'll paste this same call here. Okay, and then this one is call minus 1. So call minus 1 should be, I'll take this call minus 1. Call minus 1 should be less than, it should be greater than equal to 0. Okay, and will be like this, and call minus 1. Okay, and then here it will be will not be going call minus 1. Now we'll be doing row plus 1. So we are doing row plus 1, it means we are going up. So when we are doing up, will be the final else will be if row plus 1 is row plus 1. No, so we are going row plus 1 will be going down. So we need to go row minus 1. Then we'll be going up. If you are going row minus 1, this should be greater than equal to 0, and matrix of row minus 1, matrix of row minus 1 call should not be equal to minus 1, 0, 1, and we'll be going like this, and we'll just copy this thing. Okay, else, okay, and else we'll be doing this same call here. So I hope the sequence of the things is clear to you. So I'll go through the logic. So if you just take a look at it, this is the basic paradigm of backtracking. Okay, basic backtracking. Backtracking is nothing but selective depth first search, and that's what we are doing over here. This any traversal, any movement here and there can be simulated with depth first search. You need to do depth first search little with some um, proper logic, and that depth first search will simulate any traversal. Okay, so we should keep our logic as close to depth first search as possible, so that this because this depth first search is the Ramban. Okay, so this is the Ramban of our our algorithm problem solving technique, and we should try to use this technique again and again. Okay, and if we keep our logic as close to depth first search, then that should be there in our mind all the time. Okay, so with this having said all this, I would like to, just go through the logic once more. So first of all, I'm going to declare this result. Okay. Need not have declared the result. You could have directly, removed it, and you could have, directly passed one, new array list like this. Okay. So new array list of, let's say we are not declaring the, we are not using the right hand side, so we can declare the integer thing over here. And then here we are asking, like, we will be taking on a list of integer. So let's see whether this program is running or not. Okay, so some errors are there. Okay, it's comma is there, it should not be comma. Okay, run. Okay, return result. So return result is not there, so we should be keeping the result somewhere. Okay, so this is the need of this. We need to, we need to have this. So we'll be passing this. So now we have to, because we are not returning anything. Okay, so we'll copy this and then result like this, and then we'll move. Okay, so there is some error in this. 1, 2, 3, and direction equals down. Row plus 1. Row plus 1 is less than matrix dot length is not equal to minus 101. Okay, and go spiral. Row plus 1 call down. Okay, so like this we need to go ahead. Yeah, so we see that in the output we are not getting the full and complete output which we should get. So our right is functioning clearly. 1, 2, 3 is coming, but it's not going down. It should go 3, 4, 7. I'm going to say 3, yeah, 3, 6, 9. So that is not going. So let's see, is there any problem here in this call which is going down? Or call plus 1. So it should not be call plus 1. It should rather be in the same call, but it should go row plus 1. Row plus 1 call down, yeah. And then row call minus 1 left. Row minus 1, row minus 1 call up. Row call plus 1. Row call plus 1 right. Yeah. So now it will work. Perfect. So it's accepting. And now we'll submit this. Perfect. So this is the way to solve this problem. If you have any doubt, please write the doubts in your comments, and I'll definitely try to answer them. Thanks a lot.